um, here we are required to prove that a plus b, the absolute value of a plus b is less or equals to the absolute value of a plus the absolute value of b. This is a triangular inequality theorem that states that. So now I'm about to prove it. So without wasting any much time, let me just get straight to the point. Okay, let me just get straight to the point. Okay, now, so as we all know that if a square, if a is equal to b, then a squared has to be equals to b squared, right? Then that means now, or you know what that tells me? Okay, then that tells me that this here, which is, okay, suppose that this guy right here, which is a absolute value of a plus the absolute value of b is equals to if this is equals to this, then the square of this is equals to the square of this. But now let's do it this way. Suppose now that if this, then this, a plus b all squared, if these are equal to each other, then these two must be also equals to each other. I'm respecting this equal sign here. Okay, now let me make this my left hand side, make this my right hand side, right? Then now let me take my left hand side. I'm sorry about that, the noise. My left hand side is a plus the absolute value of b all squared, right? Now, which method are we going to use? Here you can use your FOIL method, open two brackets, apply your FOIL. You can also use the SMS method, which is the shortest one. So I'll just use the SMS method. Hopefully you all have heard of the SMS method. Here I'll just square the last, that is absolute value of a squared plus 2a absolute value of a times the absolute value of b plus the absolute value of b all squared equals to this. Then now remember that for all a in the set of real numbers, the absolute value of a squared is equal to a squared. You can prove that on your own. And also remember that in this set of real numbers, let me just say, and the absolute value of a is greater or equal to a, right? You can just try 1 and -1, try your a equals to -1, then you will see what I'm talking about. And also, let's say this set was for all a and b in real numbers, then this happens. You are supposed to be knowing that. Okay, quickly, I just want to create some room. I'm sorry. Quickly, that is now, because of these conditions, I can just flip this, and we all know that if the left hand side is equals to this, then I can just take this and substitute it here. Then let me do that. I'm just lazy to do that. Okay, so now because of those, then this is the same as a squared 2ab plus b squared. Hopefully people are with me. Okay, now then this here is the same. This here is the same. Actually, it's greater. This here is equal to what I'm about to write here, but because I've said this is greater or equals to this, then allow me to take this and substitute it here. Allow me to write this way so that you all understand what I'm trying to do. I need some room. I need to make some room. Okay, hopefully I understand and don't enjoy. Feel free to ask any question down below in the comment section. I just took this, substituted it here. Okay, let me proceed. Okay, then now this is greater remember that this is equals to this, ne? So in the place of this, I can simply substitute this. So I can simply substitute this, right? This is greater or equal to this sign, and remember, in the place of this, I can just write this as a plus b all squared. You can open two brackets, find factors and all that, but trust me, this will bring you here. Then now from this step, let me keep my sign. A plus b all squared is less or equals to the absolute value of a plus the absolute value of b all squared. From here now, allow me to square both sides so that I can get rid of those squares there. If I take the square of this side and also take the square of this side, remember that for all x in real numbers, the absolute value of x is equal to the square root of x squared, right? So now if you can see here, this is the square root of a plus b squared, of which tells me that, oh, because of this, then I can simply write this as the absolute value of a plus b. Then now allow me to simply write this. Remember that this is a square root and that is a square, then this and that, they go out or they cancel each other. You know how. To remind you, the square root, this here is equal to a squared to the power of 1 over 2, which is equals to a to the 2 times 1 over 2, which is equals to a to the power 1, because this and that goes out, which is equals to a. Hence now I'll just say, this and this, they cancel each other, so that I am left with absolute value of a. I'm sorry about my camera. So I'll be left with absolute value of A plus the absolute value of B. Exactly the same as that. Now my proof is complete. So now yenze mfutshane yonke lento ndiyiqukumbele. Into esiyenzileyo apha, you can just conclude that the left hand side is gray. Where's my left hand side? But this side is greater or equals to that side. Can simply do that. Now this is what happened. I just took this side, then I squared it. I took that side, squared it, or I have used this side to prove this side. So upper ndithathe lona, then namsquare. Then from upper I applied my SMS method to find this. But because this is equals to this, that means that even here on this space, I can just substitute this here, right? So I took this and then I substituted upper. From upper, because of the reasons ebendizivezile ubana ngaba absolute value of A is greater or equals to A and absolute value of B is greater or equals to B for ama real numbers. That means that I need to include a greater sign up and figure kule ndawo, then ndehla nayo, yabo. Then when figure up, but then how I got here, it's because of this definition here, absolute value of x. Then now when figure up, as I took the square of both sides, then this is what I got on my left hand side. Then when the tata square of this is what I got. Then the proof complete. 076 237 37 31. For more,